All right, so time for example number 3. X plus 2 over 3 equals x over x minus 2. Just like before, this one diagonal here is going to be x plus 2 times x minus 2. And my other diagonal is going to be 3 times x, so that's going to be 3x. All right. So the left-hand side, just like I did in example number 2, I need to multiply those two binomials using the box method. So I'm going to do that off to the side here. So this will be x plus 2 and x minus 2. So x times x is x squared. This will be minus 2x. This will be 2 times x, so 2x. And 2 times negative 2 is negative 4. All right, so when I put that all together, x squared. Now notice here in my diagonal, I have 2x and negative 2x. Those are actually going to cancel each other out. So 2x and negative 2x cancel each other out. So my final one for this is just going to be x squared minus 4. So I'm going to have x squared minus 4 equals 3x. Okay, it's a different looking quadratic, but it is still a quadratic because we have an x squared term here, which means I need to rewrite this so that it is set equal to 0. So the only way to do that is to subtract 3x from the right-hand side. 3x minus 3x makes this 0. Now over here, notice there's nothing to line up the minus 3x under. Okay. I can't line it up under the x squared because that is not a like term. And I can't line it up under the minus 4 because that's not a like term either. So you might remember from the previous unit I said in cases like that, we're going to just tack that on to the end. So x squared minus 4 minus 3x equals 0. Now, notice this is in a different form, not a different form, but notice the terms are in the wrong order. Normally in a quadratic, we have the x squared term, then the x term, then the constant term. In this case, this order here is switched. So I am well within my right to go ahead and switch the terms so that they're in the right order. So I can rewrite this as x squared minus 3x minus 4 equals 0. That is completely mathematically legal, all right, as long as the signs are the same. I just switched the order. So that gives me x squared minus 3x minus 4 equals 0, which is in a form that we know. Again, we could either factor or we could use the quadratic formula. In this case, I am going to choose to use factoring, to factor. Right, so that means I'm going to do the add multiply thing. So what adds up to negative 3 and what multiplies to negative 4, that is going to be, let's see, negative 4 and positive 1. Will that work? Negative 4 plus 1 is negative 3. Negative 4 times 1 is negative 4. So yes, that will work. So I can go ahead and set both of these factors equal to 0 and solve for x. So this will give me x equals 4. And the other side will give me x equals negative 1. X plus 1 equals 0, so x will be equal to negative 1. Whoops, not sure what happened there. Here we go. X equals negative 1. So, again, this was an interesting one because when I subtracted the 3x from both sides, the terms ended up in the wrong order. But again, like I said before, you are well within your right to switch the order of the terms so that they are in the right order. By switching the order here, that made it easier for me to factor and get our solutions of 4 and -1.